Welcome to RenEnergy.com, your renewable energy and sustainability platform. At RenEnergy.com, we believe in the power of clean, sustainable energy to transform the way we live and work. That's why we offer a range of solutions for businesses and homeowners looking to switch to renewable energy sources such as solar, wind, and water. Welcome to an extraordinary exploration of hydrogen gas turbines. We're delving into the future of energy, tapping into the most abundant element in the universe, hydrogen. Fasten your seat belts, because we'll break down the mind-bending science behind turning hydrogen into powerful, sustainable energy. We'll cover everything from the nuts and bolts of these marvelous machines to their role in our energy landscape and the companies pushing the envelope. Don't miss out, because today we're not just talking about technology, we're talking about the potential to revolutionize how the world is powered. Basic concepts. What is a gas turbine? Imagine a revolving door that never stops, relentlessly converting fuel into raw mechanical power. That, in essence, is a gas turbine for you, a mechanical marvel that breathes in air, mixes it with fuel, sets it ablaze, and then harnesses the resulting force to do work. Unlike a reciprocating engine, which operates in discrete strokes, a gas turbine is a symphony of continuous flow. Picture a set of fans nested inside a metal casing. As one section compresses air, another mixes it with fuel and ignites it, while a third captures the force to spin a shaft. That spinning shaft can be linked to anything from an electric generator to the propellers of a ship. Why hydrogen? Now, why would we want to fuel this mechanical ballet with hydrogen? 3 words: clean, abundant, and efficient. Hydrogen is like the VIP guest at the energy party. When burned, it leaves behind only water vapor, offering an eco-friendly alternative to fossil fuels. It's also the most abundant element in the universe, so we're hardly going to run out of it. Moreover, hydrogen packs a serious punch in terms of energy content. It has a higher energy density by weight compared to conventional fuels, making it a lightweight yet potent energy source. So, in the quest for greener, more sustainable energy, hydrogen is increasingly looking like the star of the show. Components of a hydrogen gas turbine. Compressor. Let's kick things off with the unsung hero of the gas turbine, the compressor. Think of it as the lungs of the operation. Its job? To suck in huge volumes of air and compress it to high pressures. But this isn't just any compression, it's almost like the air is being squeezed into a more concentrated form, a process that makes it far more reactive when it encounters fuel. Modern compressors can be axial or centrifugal and are designed to be highly efficient, often utilizing multiple stages of blades to achieve the desired compression. The more efficiently a compressor works, the better the performance of the gas turbine as a whole. Combustion chamber. Next, we journey into the heart of the machine, the combustion chamber. Here, the compressed air meets its energetic dance partner, hydrogen. Picture microscopic droplets of hydrogen fuel getting intimately mixed with high-pressure air. Igniters, akin to very robust spark plugs, initiate the combustion process. Upon ignition, the hydrogen and oxygen molecules rapidly react in a controlled combustion process, producing significant heat and forming water vapor as a byproduct. This combustion creates high temperature, high pressure gases, which are ready to do some serious work. Turbine. Finally, we arrive at the turbine, the section where all the prior preparation pays off. Imagine a windmill but operating at jet speeds and supercharged by combustion gases hotter than molten lava. The high temperature, high pressure gases from the combustion chamber flow over the turbine blades, causing them to spin at incredible speeds. This rotational energy can be converted into electricity or used for mechanical work, depending on the application. Turbines are engineering masterpieces, made from advanced materials that can withstand extreme conditions while operating efficiently. Each of these components, the compressor, the combustion chamber, and the turbine, plays a critical role in the seamless operation of a hydrogen gas turbine. Together, they convert hydrogen, the simplest element in the universe, into usable, efficient, and sustainable power. Operational steps. Air intake. So, how does this all come together in action? First things first, air intake. The entire system needs a constant supply of air to function. Specialized intake systems guide ambient air into the compressor. Think of this as the gas turbine taking a deep breath, preparing for the intense activity to come. Some designs even include filters to remove any particulates that could interfere with the operation. The cleaner the air, the smoother the operation. Compression. Once the air is in, the compressor kicks into gear. Imagine the air molecules getting cozy as they're squeezed tighter and tighter, their energy ramping up with every stage of compression. The compressor acts like a super efficient bellows, making the air ready for a powerful combustion reaction. In fact, without this crucial phase, the combustion chamber would have nothing to work with, leading to poor performance and low efficiency. Combustion. Here comes the showstopper, the combustion chamber. This is where the compressed air gets an energetic makeover. Hydrogen fuel is introduced into this high-pressure air environment, creating a combustible mix. A spark from the igniter, and voila! An explosion of energy takes place. It's a controlled, ongoing explosion that sustains the operation of the turbine, but it's no less awe-inspiring. Energy conversion. Now, let's talk about what we're all here for, turning all this activity into usable work. The hot, high-pressure gases created by the combustion rush over the blades of the turbine. Like a windmill in a hurricane, the turbine spins incredibly fast, generating rotational energy. This is the point where the system's stored energy turns into actual mechanical work, which can then be converted into electricity or used to power large machinery, depending on the application. Exhaust. Last but not least, let's discuss the end of the line, exhaust. You might be wondering what happens to all those gases post-combustion. The beauty of using hydrogen is that the primary byproduct is water vapor. However, there are some concerns about minor emissions like nitrogen oxides, NOx, but these are generally much less significant than the pollutants emitted by fossil fuel-based systems. And there you have it, a snapshot of a hydrogen gas turbine's operational steps, from drawing in air to expelling exhaust, converting the most basic elements into phenomenal energy along the way. Distinguishing fuel cells and gas turbines. Basics of fuel cells. Before diving into how these two technologies differ, let's get a quick refresher on fuel cells. Envision hydrogen and oxygen entering a system, leading to the production of electricity, heat, and water as byproducts. That's essentially a fuel cell for you. At its core, a fuel cell consists of an anode, a cathode, and an electrolyte membrane. Hydrogen gas is fed into the anode, and oxygen, from the air, into the cathode. Through a catalytic reaction, hydrogen atoms are split into protons and electrons. The electrons travel through an external circuit, generating electricity, while the protons pass through the electrolyte membrane to combine with oxygen, forming water. Basics of gas turbines. By now, you're familiar with the intricacies of gas turbines, but let's summarize. A gas turbine is a continual whirlwind of energy conversion, taking in air, compressing it, mixing it with hydrogen, combusting the mix, and finally extracting mechanical energy from the resulting high-temperature gases. It's a mechanical symphony that has multiple applications, from power generation to propulsion. Key differences. Now, the moment we've been waiting for, the key differences between these two hydrogen-powered wonders. Efficiency. Fuel cells are generally more efficient at converting fuel to electricity. They operate at 40 to 60% efficiency levels, and some types can even reach 85% when heat recovery is used. Gas turbines, on the other hand, tend to have lower efficiencies, usually around 25 to 40%. Emissions. Both technologies have low emissions compared to fossil fuel counterparts, but fuel cells have an edge. They emit only heat and water, while gas turbines may produce trace amounts of nitrogen oxides. Applications. Fuel cells are often found in smaller, more localized settings like backup generators, cars, and buses. Gas turbines are generally used in much larger applications requiring high power outputs, like industrial plants and aircraft. Complexity. Gas turbines have a more complex mechanical setup with moving parts, which may require more maintenance. Fuel cells, by contrast, have fewer moving parts, making them easier to manage over time. Energy output. Gas turbines can produce enormous amounts of power, making them more suitable for grid-level energy production or large vehicles like ships and aircraft. Fuel cells are usually better for lower power applications. Startup time. Fuel cells can generally start up and reach operating efficiency more quickly than gas turbines, making them useful for applications requiring rapid startup. Understanding these key differences can help us appreciate where each technology shines and how they can complement each other in the quest for cleaner, more efficient energy solutions. Industry involvement. The potential for hydrogen as a fuel has ignited a firestorm of innovation in various sectors of the automotive industry. From big, burly trucks to sleek, efficient small cars, companies are investing in both fuel cells and hydrogen gas turbines to power the vehicles of tomorrow. Here's a look at some key players. Companies in big trucks. Nikola Motors, this American company is all in on hydrogen, aiming to revolutionize the trucking industry with its hydrogen-powered big rigs. They're not just stopping at trucks. Nikola has plans for an entire ecosystem, including hydrogen refueling stations. Kenworth, a venerable name in the trucking industry, Kenworth has been dabbling in hydrogen technologies as well. They've been testing hydrogen fuel cell versions of their heavy-duty T680 trucks, signaling a possible shift in the industry's future. Hyundai in commercial vehicles. Hyundai is not just involved in small cars, they're making waves in the commercial vehicle sector as well. Their Hyundai Shint fuel cell truck marks an earnest entry into the hydrogen-powered commercial vehicle market. Companies in small cars. Toyota Mirai. Toyota has been a pioneer in the automotive industry, and its Mirai model is no exception. This hydrogen fuel cell vehicle has been praised for its range and quick refueling times, serving as a benchmark in the small car segment. Honda Clarity. Honda's Clarity fuel cell offers another promising option for hydrogen-powered personal transportation. Its elegant design and impressive range make it a strong contender in the growing market for eco-friendly cars. Hyundai Nexo. Rounding out our list is Hyundai's Nexo, a compact SUV fuel cell vehicle that offers a blend of efficiency and utility. With its advanced features and a range that rivals conventional vehicles, the Nexo is showing that hydrogen can be a practical, everyday choice. Whether it's hulking commercial trucks or nimble passenger cars, hydrogen is proving to be more than just a niche fuel source. It's shaping up to be the backbone of a greener, more sustainable transportation network. Challenges and considerations. The path to a hydrogen-powered future is exhilarating but not without hurdles. Whether it's in engineering, efficiency, or emissions, there are complex challenges that scientists and engineers are tirelessly working to overcome. Let's delve into some of these key areas. Engineering challenges. Hydrogen storage. The elephant in the room is hydrogen storage. Hydrogen has a low energy density by volume, which means storing it effectively is a challenge. Unlike liquid fuels, hydrogen often needs to be stored under high pressure or at very low temperatures, both of which pose engineering and safety challenges. Combustion characteristics. Hydrogen has a different combustion profile compared to conventional fuels like gasoline or diesel. For instance, hydrogen has a wide flammability range and burns with a nearly invisible flame. These unique characteristics require specialized combustion chambers and detection systems for safe operation. Material compatibility. Hydrogen is a small molecule that can be corrosive to certain materials over time, potentially leading to leaks or structural issues. This calls for advanced materials that are hydrogen compatible, increasing the complexity and cost of system components. Efficiency and emissions. Efficiency. While hydrogen gas turbines can be impressively efficient under certain conditions, they generally lag behind fuel cells in terms of energy conversion efficiency. Typical hydrogen gas turbines operate at efficiencies between 25 to 40%, whereas fuel cells can reach up to 60% or higher, especially when heat recovery is factored in. Emissions. The good news is that hydrogen combustion primarily produces water vapor, drastically reducing CO2 emissions. However, the combustion process in a gas turbine can still produce nitrogen oxides, NOx, which are pollutants. This is less of an issue in fuel cells, which don't involve combustion in the same way. Life cycle emissions. A comprehensive view also considers emissions from hydrogen production, transportation, and storage. While hydrogen itself is clean burning, the overall environmental impact depends on how the hydrogen is produced. Methods like steam methane reforming are less clean than water electrolysis powered by renewable energy sources. The challenges are many, but the promise of hydrogen as a clean, sustainable fuel is motivating continuous advancements in technology and engineering. As we fine-tune these systems, the goal is to achieve a level of efficiency and reliability that makes hydrogen not just an alternative but a first choice in sustainable energy. Conclusion. Summary and future outlook. As we've seen, hydrogen gas turbines offer an intriguing blend of proven mechanical engineering and forward-thinking sustainability. They're part of an evolving landscape in energy production and transportation, working alongside other technologies like fuel cells to pave the way for a cleaner, more efficient future. From the basic components like compressors and combustion chambers to the intricate operational steps, hydrogen gas turbines are a marvel of modern engineering. They're already making their mark in various industrial settings and have the potential to transform sectors like aviation and maritime transport. However, the path is strewn with challenges. Issues surrounding hydrogen storage, combustion characteristics, and efficiency are being actively researched. It's a transitional period where significant strides are being made in material science, engineering design, and emission control measures. So, what's on the horizon? With the increasing focus on renewable energy sources and reducing carbon footprints, hydrogen gas turbines stand to gain significant attention and investment. Companies from diverse sectors are jumping into the hydrogen arena, developing everything from heavy-duty trucks to compact, efficient cars. As more eco-conscious policies come into play globally, it's likely that we'll see accelerated development and adoption of hydrogen technologies, including gas turbines. It's an exciting time, filled with challenges but also teeming with opportunities. Hydrogen gas turbines, with their blend of high power output and reduced emissions, could well be a staple in our sustainable energy toolkit in the years to come. Thank you for choosing ReneEnergy.com as your go-to source for all things renewable energy and sustainability. With our YouTube channel, we explore the latest developments and innovations in the field, including hydrogen fuel cells and the use of AI and machine learning to optimize energy consumption. If you're ready to take the next step towards a cleaner, more sustainable future, visit us at ReneEnergy.com and discover the many ways we can help you transition to renewable energy. Thank you for watching and subscribing. Stay up to date on all the latest news and insights by subscribing today.